Good morning to you all present over here, respected our subject teacher and my dear friends. It's me Nitesh Pariyar.
I'm Alexis. I'm Sunil Sharma.
Today in front of you all to present our presentation on the topic matrix. Without any delay, I'd like to start with the overall content. Matrix is a very easy topic and we have been discussing it over since our junior classes. So at first, I like to explain you about matrix. What is matrix? Matrix is the representation of numbers in the form of rows and columns, which is enclosed by a square bracket or a round bracket. For example, A is equal to 1, 2, 2, 1, 2. This is an example of matrix. We have been studying it from the previous classes. So without wasting any time, I'll give you different type of matrix which are necessary for inverse of the matrix. At first, identity matrix, which means the diagonal of the matrix will be 1, 0, 0, 1. This is the example of identity matrix. Although we need symmetric matrix and skew symmetric matrix, where the symmetric matrix means the element in the for example, A is a matrix in which element in Aij and Aj will be equal. Similarly, skew symmetric matrix is such matrix in which elements in Aij will be equal to minus Aij. You can easily understand that because in the book it is easily explained. Another we need is 4 basic operation of the matrix, which are addition, subtraction, multiplication, and multiplication by a scalar constant. In which addition and subtraction, for addition and subtraction we need same order of matrix, and for multiplication of matrix we need column of first matrix and row of second matrix equal. Without that we cannot perform multiplication. Another we need is transpose of matrix. Transpose of matrix means interchanging the rows and columns. So I give the example of this with transpose AP is equal to, if I interchange the row and column, it will become 0, 1 and 1. No, it's 2. Sorry, 1, 2. Is the example of transpose of matrix. There are 4 basic properties of matrix. They are given in the book. They don't need to be explained because we are not going to study it in deep. Another is there are 3 theorems given on the topic on this transpose, which are also in the book. You can easily understand. No need to time waste. And another very important topic is inverse of the matrix. Inverse of the matrix means if two matrices are given A and B, the product of this matrix will be equal to identity matrix like this. For example, A and B are 2 matrices, then their products will be A, B is equal to B, A is equal to identity matrix. If this condition is possible, then only the inverse of these 2 matrix is possible. Without this, we cannot take our inverse. Similarly, another important formula is A is equal to adjoint A of A, and discriminate that this formula. With this formula, we can take the inverse of any matrix, and this should be explained with the only example. I cannot explain you with my words, so I like to call Alex for inverse of the matrix.
Good morning, everyone. I'm Alex. Today I'll be solving 2 questions and explain it later on. For matrix is given to us and we have to find the inverse of it. So it is the formula of adjoint A. To find the inverse of the matrix, we have to divide the adjoint A by its determinant. After dividing, we get the matrix as 16. To find the inverse of it, we have to firstly find the value of adjoint A, which is the transpose of cofactor of A. So it is the cofactor of this given matrix and its transpose is this. And second, we have to find the determinant of A. So its determinant is 32. Now in the question number 6, we have given a matrix and we have to prove that A product of A and adjoint A is, we have to find the product of A and adjoint A without finding the adjoint A. So we have a formula of it is equal to the product of determinant of A into identity matrix. So expanding row 3, we get
I'm going to tell some properties of a transpose matrix. Here, A3 upon A2 is A matrix and A plus A It is symmetric matrix. And A minus A is skew symmetric matrix.